Here we have a worked example on how to use the simple harmonic motion equations. And our question says a particle is in simple harmonic motion with an amplitude of 20 meters and an acceleration of minus 16 times the displacement. Find the period of oscillation, the displacement, velocity and acceleration after 2 seconds, and the time taken to move 10 meters from the center of oscillation. The first thing for us to do then is to interpret the question, and the question tells us clearly that the amplitude is 20 meters. It tells us rather bizarrely that the acceleration is minus 16 times the displacement, but because it tells us that it's in simple harmonic motion, we know the acceleration is minus omega squared times the displacement, x. So from this we know omega. So there's our question interpreted. It asks us for the period, so we need a connection, or an equation, which connects the period t and what we know from the question, the amplitude, the angular speed. And we know that period is 2 pi over omega. And so we know the period is pi by 2 because omega is 4 radians per second. Now in maths you might well be able to leave that as pi by 2, but in physics we have to consider the number of significant figures that we have, and so we look at this and we say we've got 2 sig figs, and so we need this to 2 sig figs, 1.6 seconds. So that's part 1 done. Part 2, displacement, velocity and acceleration after 2 seconds. Well, we know that x equals a cos omega t, and we know a, and we know omega, so we can stick our numbers in there then. And we get x equals 20 cos of 4 times 2. Now, just a quick reminder here, if a reminder is needed, that this is an angle in radians, so make sure your calculator is calculating in radians. Otherwise, you'll get the wrong answer, of course. So minus 2.9 meters is the answer there. And the minus tells us that it is below the equilibrium position. Then we have our velocity. And we know that our velocity, is a omega sine omega t. And so if we stick in our numbers to that, we get 20 by 4, which is a omega, sine 4 by 2, which gives us 79 meters per second. Now you might look at that and say, oh, that's very quick. However, if you look at the amplitude and the angular speed, this thing really needs to be shifting. To have an amplitude of 20 meters and a period of 2.9, a period of 1.6 seconds, it really does have to be moving quite quickly at times. So that's a sense check on whether or not what we're doing here is right. And then finally, for this part, we want the acceleration. The acceleration is minus omega squared x, of course. So we'll write that down and stick in our numbers. Omega is 4, so that's minus 4 squared times x, which was minus 2.9. Notice I'm taking care to put my minuses in there, and that's going to give me 46 meters per second squared. And again, you might think, well, that's quite a lot. But then looking at the stem of the question, it is definitely realistic. And then finally, the time taken to move 10 meters from the center of oscillation. Well, as we said before, x equals a cos omega t. So x is 10. Is the amplitude 20 by cos 4 times t, it's t we're after. So cos of 4t would be a half. And so t is the inverse cos of a half over 4. And so that gives us t equal to 0.26 seconds to 2 sig fix.